Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are starting with the next part of the atomic physics, which is the last part, and we are doing the introduction to the nuclear physics today. And from there, we can start the nuclear physics part, and we are looking forward what are nuclear physics, what the things we include in the nuclear physics, and we go in some stand of the nuclear physics part. So let's start with the uh, what is there going on in the nuclear physics. So in 1918, the Rutherford began a new set of experiments where he bombarded nitrogen gas with alpha particles. Rutherford noticed that some of the nitrogen gas transmuted, converted to a different chemical element. So in 1918, Rutherford do some experiments and they bombarded the nitrogen gas with the alpha particles, and they noticed that nitrogen gas is transmuted. So here's what transmuted means. So transmuted means converted to a different chemical element. Uh, they go into different chemical element into oxygen with the production of the some hydrogen nuclide. So there's some hydrogen can produce and the oxygen can produce with the transmutation of the nitrogen gas. The presence of the nitrogen nuclide allowed Rutherford to conclude that they were the fundamental particle that is a constituent of all the nuclei, and the particle has been the proton. So from here, the Rutherford can again discover the proton by this experiment. You don't have to know about very much in this experiment. You just want to know that Rutherford can discover the proton with the transmutation process. While this was another advancement in atomic physics, the story was still not complete. Protons could not account for all the mass of the nucleus. In 1920, Rutherford proposed the idea of a neutral particle called the neutron. So there is advancement in atomic physics again, but their story is not complete yet. Then protons could not account for all the mass of the nucleus. The mass of the nucleus, so there's a nucleus and there's an atom and there's electrons over there in the orbit. You know that. So the mass of the nucleus cannot account for all the protons in that thing. On the nucleus, we have a proton. So nucleus is made up of the protons, and they proposed the idea of the new particle, which is the neutral particle called the neutron. So the neutron is also over there present in that. So proton has the positive charge in that case, and this has a zero charge neutral particle. So the positive charge of the neutral particle can be in the nucleus, they inside the nucleus, which will account at the mass of the nucleus, which had roughly same mass as the proton. So they have the same masses. And from here the proton and neutron is discovered by the Rutherford. And we use involved this lesson with the proton and neutron. So some of the nuclear notation and some terminology before starting with actual nuclear physics. So in an atom, there are three particles of interest. So we discover the three particles. Electrons can be discovered at the first by the Thomson model. Then with advancement, we discover the nucleus, and in the nucleus, we conclude that they are the protons and the neutrons in the nucleus. So they have some charge, they have some mass, and they have some mass in like U. U we will I will explain you what is the U in this lesson too in the last. So we have electron which has a charge of -1, and this is the mass of this. So charge and mass is all given to in your data sheet, so you don't worry to be memorize this. And in U basically is the atomic mass unit. We discussed that, and we will going to discuss that in the at the end. But this is like a conversion from kgs to U. We conversion that we need to have to solve the questions related to that nuclear physics questions. Then a proton has the positive one, and this is their mass, and this is a 1U. Neutron 0 is a neutral, same mass as the proton, and there's U in the 1U. In the table, 1U is equal to this. So 1U is equal to 1.66 into 10 raised to minus 27 kgs. Thing, this conversion is given to in your formula sheet, so don't worry. And more on this soon. As the protons and neutrons aside in a nucleus, they are referred to as the nucleons. So protons and the neutrons are reside in the nucleus. They are inside the nucleus. So that whole thing, that the combination of the protons and the neutrons inside the nucleus, that referred to as a nucleons. That's a new word we introduced there. Nucleons, which are made up of like protons and neutrons when they are reside in the nucleus. In the nuclear physics, there are the three important numbers that we need to know to study the radioactive decay. The radioactive topic we discuss in the next video, that what is radioactive decay. We doing full lessons on that. So basically we have to know about three numbers for this. So what are those three numbers over there? Atomic number, neutron number, and atomic mass number. You are familiar with the atomic number and atomic mass number, which is in the chemistry too. When you're doing the any matter thing, when you do the elements and the whole thing, when you do. So these are the same. These are the on the periodic table. So for this, you need a periodic table too. So the periodic table is given to you uh, in the like examination of this unit. So atomic number is denoted by this Z, and this is actually the number of the protons in the nucleus. So number of protons in the nucleus is equal to an atomic number, which is denoted by the Z. You can read directly this number from the periodic table. This is the Z, and yeah, so you can directly see that number, that element number. Like hydrogen is 1, helium is 2, then lithium is 3. So this is a number in the left corner of the left top corner of the element box. So you can see those this atomic number. Neutron number is the number of the neutrons in the nucleus. That thing you have sometimes you have to find, because the atomic mass number, which is the number of the nucleons, which is Z plus N. When you to find the A, you have to do Z plus N. Z you can find easily. A is given to you. So for N, you can find the N from here, which is A minus Z. So N is always you have to find sometimes, that they're not given that more frequently in the nucleus, and this number usually given. It is approximately the atomic mass of the atom expressed in atomic mass units. More on this video. So we generally write the comparison composition of the nucleus and the nuclear in the nuclear notation like this. So H is any element. So our H is any element given to you. From this is the kind of the notation of the isotopes. So from here we can start doing what is isotopes. So an isotope is a variant of the particular chemical elements. So we have a particular chemical elements which they have isotopes. It has the same number of protons. So same number of protons means they have a same, like Z is same, but they have different A. So they have different number of neutrons. Oh no, they have different number of neutrons, which is N. So they have different number of neutrons, which is your N. So we have example of now hydrogen over there. So ordinary hydrogen. So like ordinary hydrogen, which is the ordinary one, which is 1 1. We have 1 and 1, or up and down. Then we have a deuterium, and then we have tritium. So this has like 1 and 2, and this has the 1 and 3. So your A is continuously changing, but your Z remains the same. As an isotope has the same number of protons and electrons, they have almost identical chemical properties. However, the physical can be different. So isotopes have the same number of protons and the electrons, so they have almost same identities, same identical chemical properties, but their physical properties are different because of their changing. And one isotope would be very stable while another would be radioactive. So carbon 12 is stable versus carbon 14 is very radioactive. Sometimes the radioactive thing we discuss in the next lesson, but you have to know this for now, that some, like if they have like carbon 12, so carbon 12 is very stable thing, but the carbon 14 is very radioactive, which is very reactive thing that can be react with anything else. Radioactive means that the things which very reactive very fast. So there's comparison between that. So isotopes could be very stable and sometimes they're very radioactive. So that's the thing we discuss in the next lesson, and you have to know about this very soon. Next thing, the last thing, that the U is known as the atomic mass unit. And you use the U sometimes because you have to convert the things from the kgs to U to use in the formulas. So the base unit of the measuring mass is SI, is the kilograms. For everyday objects like a table or a person, this is a great way of measure mass. However, for the things that are extremely tiny, so the atoms, atomic scale, they have extremely tiny things. On the atomic scale, the kilogram works, but it is not most convenient. because sometimes you get the very big values. To make that value very small, you have to use the U values. So for subatomic particles, they generally look at using the atomic mass unit, which is the U. So from here, the U can be coming. This is atomic mass unit. Defined is as the 1/12 of the mass of the carbon 12 atom, and the value of this is sometimes this, but we rounded that value to 1.6 in 10 raised to minus 27 kg, and that value is given to you in formula sheet. So 1 U is equal to 1.66 into 10 raised to minus 27 kgs. So that value you have to know, and we use that value in the question. So we have example over there. We have one example. So for the following isotope, write them in the nuclear rotation. Determine the number of neutrons, protons, and nucleons. Determine the nuclear charge in coulombs, and determine the total mass of the nucleons in kgs. We have a cadmium 114. So that 114 thing is your A. So 114 thing is always your A is given to you. So we have to know that which cadmium has the element half of CD. You can see from your periodic table, and 114, this is upside, and 114. So you have to know that what is Z now. You have to know what is Z now. So if the A is 114, Z is the number of protons. So this is element 48. So you can see this is the element 48. You have to find the atomic number, which is the atomic number of this. So atomic number of this is 48. So 48. So now you done the nuclear notation. You're doing the number of neutrons, protons, and nucleons. So number of nucleons, to find what you have to do with. So we have a A, we have a Z. So to find the N, we minus that. The 141 minus 48, you get N of 66. And the 66 is equal to a number of neutrons, so which means the neutrons number is 66. The protons number is 48, because Z, atomic mass number, is equal to the protons, which is 48. So for the nucleons, you have to plus this both. So nucleons have been made with the neutron plus protons number, which will get a 114, which is again that number, which is 114. So this 114 is also called this thing. Done. Then you have to find the nuclear charge. To find the nuclear charge, you have to do some formula. So you have to find the Q. In that case, for the nuclear charge, you have to use the Z value with the with the charge of the proton. Why the charge of the proton? Because they mentioned you have found a nuclear charge, and nuclear can be found with the proton only. So you use the Z with the charge of the proton. So the Z is given to be 48, and the charge of proton is 1.6 into 10 raised to minus 19 coulombs. So you will get 7.68 into 10 raised to minus 8 coulombs. Answer for that. So after that, you also have to tell me the total mass. So total mass for the mass 2. So the mass of the proton is always equal to the mass of the neutron somewhat. It's approximately same. So when you use the mass, so you have to use the A, which is the mass of the both. When you add this, you get the mass of both, and you basically again use the mass of the proton in that case. So always the mass of the proton or the charge of proton can be used when you find the total mass or the nuclear charge. So the mass is equal to A is 144, mass of the proton is 1.67 10 raised to minus 27 kgs, given in your formula sheet. And when you calculate it, we have 1.90 10 raised to minus 25 kgs. So this is your mass. That's all you can find, and that's the thing you find, this thing and this thing. So that all process you have to follow, and that all thing is related to nuclear notation or the terminology we're doing in this lesson today. So that's all for this lesson, and we discussed the more things about we just started the things about the nuclear physics, but we're more looking forward to the nuclear forces and the mass defense, which we done with in the next lesson. So like I said, where do I learn smart but not harder? Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till let's stay with EduVibe.